So the total energy given is E, right? The total energy given is E. In that E, this much energy is spent by that 1 coulomb to overcome the internal resistance. So the remaining energy will be the drop across the component. Now we call this the terminal potential difference. Terminal potential difference. Because if you look at that circuit, now if you subtract E minus the potential drop across the internal resistance, then it is the remaining, that is the VR, is the one that is dropping across the terminals of the battery, right? So that is basically across the component. So we call it the terminal potential difference. So E is EMF, R internal resistance, capital R external resistance, and VR potential difference across the load or terminal potential difference. V small r potential difference across internal resistance, or also called as lost volts. The terminal potential difference is the potential difference the terminal potential difference is the potential difference between the terminals of a cell when a current is being delivered. Now the thing is, for a potential drop to happen, there are two necessities. One is, yes, there should be a resistance, but at the same time V is equal to IR, so if there is no current, then there will not be any potential drop, right? So in this equation, E is equal to VR plus V small r. The potential drop across internal resistance is and the potential drop across the resistor, this happens only when there is a current, right? So that's why the terminal potential difference is, when you're saying what it is, you are saying that when there is a current. We're going to see what if there is no current. Now, so as you look at that equation, the terminal potential difference, that is the capital R, VR, is always going to be less than the electromotive force, because we are subtracting a value from the electromotive force, so it's going to be less than that always, as long as there is a current. So the lost volts is, now if you lost volts is V into this small r, so not into V small r, so that is equal to EMF minus terminal potential difference. So you can change the equation. Basically we have only one equation, we are just playing with the subject of the equation. So E is equal to V R plus VR. So this is your potential, the drop across the internal resistance, that is also known as the lost volts. This is the terminal potential difference, so this is the EMF. So if you look at the terminal potential difference, that is going to be E minus lost volts. VR would be E minus lost volts, so that's going to be less. And if you want to write the equation for lost volts would be equal to E minus terminal potential difference, right? So that's what's given here. The lost volts, that will be equal to E minus terminal potential difference. Now, what if there is no current? Okay, now these three quantities are related. Now, how are we going to measure the electromotive force, that is the total potential.